Hi everyone, welcome back to The Process, my 7-part deep dive into how Elixir, that's right, Elixir, not Erlang, does processes. This is part 3, which is called The Conundrum with Concurrency, Tasks to the Rescue. This chapter, in my opinion, is the most important chapter of the process deep dive. It deals with a series of niceties that Elixir provides you, and as far as I know, only Elixir provides you with these things, not Erlang, not Go, not Rust. No other platform that is designed for concurrency gives you what Elixir gives you in this episode. Everything that you're going to see is going to be in the context of tests, but all of the parts that tasks will inherently build in are built into tasks, will be there for you in test, dev, and prod, or any other environment that you desire to create. So at the end of all of this, I'll tell you a couple of ideas on how you might be able to harness that. But part 3 is going to be divided into 3 major sections. First one, we're going to talk about test mocking. The second one, we're going to talk about ecto checkouts. And the third one, we're going to do a little bit of cool stuff where we exit the VM. Okay, so the thing that ties all of these subparts together is this concept that shared global state is the enemy. Now, I know that we're functional programmers in Elixir, and often we think of functional programming as dealing with immutable stuff. And Elixir and Erlang also give on top of that a layer where each process has no shared state. But that's a little bit of a lie, because sometimes we need to have shared global state because it's computationally efficient. Maybe we're reaching into low-level code. Maybe we're dealing with operating system stuff. Maybe we're dealing with files. Maybe we're accessing a database. Maybe we're reaching out to a web service. And in any of these cases where you're doing something where you're setting something external to the process and then accessing that set state later, that's where you can have a conflict. Because if 2 processes at the same time are attempting to set some sort of state and it's shared and global, when they try to retrieve the state later, there could be a conflict. So that's what we're going to explore, how to deal with that. And one of the places where you're going to deal with that the most in Elixir is when you're testing. Because ideally you want to have all of your tests run concurrently. And inevitably, some component of your system is going to have shared global state. And you need to be able to figure out how to shard that global state so that each test sees its own view of what the universe should be, and those views do not interfere with any other test's view of what the universe should be. I call this the multiverse pattern. Elixir gives you a lot of tools to make sure that your tests exist in their own little universe, even though in reality they're completely sharing the resources of the virtual machine. And I think part of what makes this really, really powerful is that if you make all of your tests async in Elixir, you're going to not only have faster running tests, which, can't complain, right? But you're also going to stress out your virtual machine by pummeling it with a ton of requests. And if you ever have any sort of situations where you have a temporal dependency that you haven't resolved, those will show up really quickly. And if you have any weird race conditions, the fact that you're stressing out the virtual machine will expose those and make them much easier to identify, much easier to fix. Okay, so let's get into it. So like before, I have a module called Playground, and this module is going to call a mocked module. I want to make an important distinction here that I'm not using mocks. I'll show you at the end of this episode how this all works with mocks. But for now, what we're going to do is we're going to pretend we didn't have this wonderful library created by Jose Valim, the creator of Elixir, that will help you do mocks. I am not going to go over some of the philosophical details on how Elixir approaches mocks. If you're curious about that, I will leave a link to Jose's famous mocking blog post, and you should read that whether or not you should read that. Period. It's a beautiful way of thinking about how you should be doing things, and it's sort of been a North Star for how you should do mocking in Elixir. Okay, so let's go over how this module works. It's pretty simple. In test, we're going to set this module attribute module to myModuleMock, and in dev and prod, it's going to be myModule. And I've got my module here, and you can kind of just see it's just a stupid function that takes no parameters and returns unmocked in the case for dev and prod, right? And what Playground will do is it will call that module's content function and then concatenate the string that comes out, and then io.puts it. This is a very, very simple function. Let's look at what that looks like when we run it. So. And we're going to do playground.action, and then we're going to say hello. And hey, it says hello unmocked. So what happened was in dev, which is the environment that we're in, it was at compile time, it was assigned to myModule. And so myModule.content was called, and that's unmocked. And you can see hello got concatenated to unmocked. Okay, so let's just say that myModule was some sort of long and annoying internet request. Go out to foo.com and then pull back unmocked. And we don't want to necessarily have to reach out over the internet to run tests on what this module is doing. So in that case, what we want to be doing is we want to set this to a mock. And so in test, instead of going to myModule, it's going to go to myModuleMock. So let me show you myModuleMock. And this is kind of a level 0, super naive way of doing a mock. And I know I haven't showed you agents, but if you don't know what it is, look it up in the Elixir docs. It is basically the simplest way to have some sort of global shared state. And note that the myModuleMock function or module implements the content function. So that's the API for this myModule function, the content function with 0 arity. And what I'm going to do is I'm going to create an expect function, which allows me to store some function, some 0 arity function into the agent, right? And then when I store it and subsequently call the content function, instead of what it will do is it will pull the previous value and then execute it. Okay, so let's take a look at how that looks like in test. So the first thing to note is that in the test helper, I have to start up the myModuleMock. We're gonna ignore that for now. And then in a test, here's an example test that I've written. So it kind of pretends like it's doing some work. So I sleep for some random amount of time. I set the expected value of the function of the content call by passing expect a 0 arity lambda. And then I sleep for some more time, and then I call the action function, right? So let's go ahead and run this. So basically what I'm saying is pretend that action function is fn, or pretend that the content function is fn, this zero arity lambda that emits test. And then when I call playground.action, what's going to happen is it's going to concatenate the string that I passed, which in this case is test got, with the result from the expect, which is test, right? So here we got test got test. And if I do this, I can do this. And we get test1 got test1. Likewise, if I want to do more than one, I can set expectations twice. And let's do this. And then what we're going to see is we're going to see test1 got test1 and test2 got test2. Perfect. This is exactly what we would expect in a mock. So now let's throw a little bit of a wrench in the system. So I am going to go ahead and just make a second test. We're going to copy this. We're going to paste it. We're going to make a second test. And oops, we need to do this, otherwise it won't execute. And I'm going to call this test2, and then we're just going to make this test2, and then we're going to make this test2. So what do you suppose is going to happen when I run this? Let's try it again. So note that it worked out this time, but if I run it a second time, I might get something weird. In this case, test1 got test2, and test2 got test2. And let's try it again. This time I got test2 got test2, and then test1 got test2. So they might not necessarily run in the order that we expect, and they might have weird values. We expect test1 to only retrieve the value test1, and we expect test2 to only retrieve the value test2. Now, why did this happen? Well, the problem is that these two tests are running concurrently. Because I set them to async true and they're in different modules, Elixir will load up these modules in parallel and just start running them. And whatever happens whenever is when things are going to happen. And in this case, we might wind up loading this test2 value after we load the test1 value in. And then when test2 sleeps and waits, or test1 sleeps and waits to pull its value, its test1 value has been overwritten by this test2 value. That's not good. So we need to redo the way that we're doing our modules, redo the way that we're doing our mock to make sure that those sorts of collisions don't happen. So let's take a look at kind of a naive implementation on how to do this. So I'm just going to copy and paste some pre-written code that I have for how this works. Okay, so here, instead of storing the lambda that represents the content function, what we're going to do is we're going to store a map. And what the map is going to do is it's going to associate, when I call expect, I'm going to pull the PID of the calling process and associate that PID with the lambda that I've passed as my expectation. Then when I call the content function, remember this is the API function, I'm going to look up the PID of the calling process again. And this time I'm going to do map.get on the stored lookup table against this function, retrieve the previously stored lambda, call it, and then that's going to be the result of the content call. Okay, so let's try it and see what happens. This time, I get test2 correctly associated with test2, and then test1 correctly associated with test1. Let's run that again just to make sure that we don't have any weird non-determinism. And it looks pretty good. Each time I run it, test1 is correctly associated with test1, and test2 is correctly associated with test2. So the next thing we need to do is probe the limits of how far this can go. All right, so now what's going to happen if I do this? So presume that somewhere in my code, I'm running sort of like a little bit of long running code instead, and decide to wrap this io.puts function or whatever the work is in some sort of task. What is going to be the problem here? Well, let's just even run this, and we're just going to get a bunch of errors. Now, why is that happening? Because at the point that, well, one way to quickly determine what's going on is just to look at what the self values are that we've stored. So I'm just going to inspect those. And look, 8 and 13 don't match up. This is 178, 173, and 183. This doesn't match either of these other two processes. So we've got a little bit of a problem. How are we going to know that the task that we've spawned is associated with the process of the test? See, the test is running this process, and we try to use self to try and figure out, how to shard these universes of different mocks, and we don't have a way of untangling them, because by the fact that we've created this concurrent process, we can no longer tie the ID in. Okay, so I'm going to first paste a little bit of code that's going to help us fix this situation. I'm going to show you that it does indeed fix the situation, and then we're going to walk through it line by line. So fundamentally, this code is more or less the same. The start part is the same, and the general strategy is going to be identical. We're going to use a map as a lookup table that is going to associate processes with the bound function. And the expect function is exactly the same as well. So what we're going to do is when our test process calls expect to set the expectation, it's just going to put its own PID in as the key for the lookup table, and the substituted function in as the value. The place where it gets different is in the content section. What we're going to do is we're going to call the process library get function and look for the special value called $callers. I'm going to show you what that is in a bit. We're going to concatenate the calling processes PID onto there, and then instead of directly looking for the value by calling the map, we're just going to use this find fun helper function. And what we're going to do is we're going to look at all of our options of processes, and then we're going to try and match the key values in lookup to one of these options. So what this is, what the process.getCallers call does, is that when you spawn a task, Elixir will stash inside of that task for you inside of that process for you a special value called $callers, and this is a list of all of the previous callers. That's a call chain for like what process called this task and what process called that task in front of it, right? And so what we can do is we can look through this list, and eventually one of the callers is going to be, hey, that's going to be the test process. And if I can associate that test process with the function that I've set up an expectation for, then I can call that function. So this is kind of like almost a stack trace, but it's specific to, it's sort of like a process trace, if you will. It's really cool. This only exists in Elixir. Okay, so, right. So what we're going to do is we're going to assemble this list, and then we're going to put ourselves on that list. And then we're just going to go through all of these callers, right? And then just check to see if any of the keys matches. And then when that key matches, we're going to perform a lookup against that key. Pretty simple stuff. And then that's going to return a lambda. That lambda we're going to call, and then it's going to be just like before. Now, this is essentially how mocks does its mocking, although it doesn't use an agent. Okay, so let's go ahead and quickly run this mix test again, just to once again prove to you that it's working. And let's spy a little bit on the code that we have. So what I'm going to do is I am going to do this. So what we're going to do is in this action, we're going to do self, and then we're going to inspect that. And then we're going to do process.get $callers, and then we're going to inspect that. So you can see what's going on. Okay, so we're going to run mix test, and then you can see that the callers list contains the process of the task of the process that called it. All right, what happens if we do this? So now I'm going to call a task, and that task is going to launch another task. So this is going to be nested processes coming in. And you can see that the parent PID, which is the test PID, is the root in the list, and then there's another PID stashed in there. That's also the case for test2. We have the test2 test PID here, and then on top of that is stashed this test. Well, let's just double check to make sure that's the case. So we can call self and inspect it, and then we can run that again. And so you see 168, 168, 178, 168, 178, 172, 176, 172, 176. All right, let's just go one more level of crazy and then add another task.start. And then put another end here. And then you'll see that that callers list expands to a size of 3. Now there are 3 nested calls to get all the way down to our test PID, which is 167. 3 tasks callers to get down to our root test PID, which is 172. And note that the test still runs, and we still get correct association between test 1 and test 1 and test 2 and test 2, the expect values, because what it's doing is it's drilling through this list and trying to find the correct matching process, then using the associated expectation. Okay, so this is one of the reasons why you absolutely always should use the task module for running spawned processes inside of your Elixir code, whether that's task.start, task.startLink, task.async. All of those, the task module will provide you with the infrastructure that will put the correct callers inside of your callers library. And if you have a mocking system like this fake mock system that I just wrote, it can take advantage of those callers to find the test PID. And mocks does exactly the same thing. I'm going to demonstrate that in the next video to kick us off. And then we're going to work through how this works with database checkouts. Okay, see you next time.